Hi there, Tony Verbsky here. Just getting ready to do a lecture over section 2.2. What I think is I would like to do one problem before I start. So this may be abnormal for a start, but I want to get right after it. So lecture, Metro State, 1080, section 2B. Then I want to start converting 55 miles per hour to blank feet per second. Now, I've done this since I've been in high school. My teacher, Mr. Jensen, taught me this. So what I would do is I would write down the problem, and then I multiply by a series of funny looking ones. And I want to get rid of miles, and I like feet upstairs. I know in 1 mile, we live in Denver, 5280 feet, and look what happens. The miles are gone. Then I'm going to multiply by another funny looking one, and I would like seconds on the bottom, and I'd like to get rid, I would like to get, I got feet per second, I want to get rid of hours. Sorry. In 1 hour, there's 60 minutes, and there's 60 seconds each minute, so there's 3,600 seconds. And hours cancel, and you can see we're left with feet per second. This is a funny looking one. This is a funny looking one. And now in math, we book straight across and multiply things out. So it's 55 times 5280 divided by 3600. Oops. Here we go. See if I can. Whoops. There we go. Let's try this again. 55 times 5280 divided by 3600 is 80.6 repeating. 80.6666 forever. Let's say we want to round to the nearest thousandth. Oop, don't forget the units. Feet per second. And let's go to the nearest thousandth. That means we look at this digit, and if it's 5 or over, we round this digit up, and we get 80.667. Here we go, feet per second. And that's what I used to do when I was younger. So section 2B, there's a lot of problems in here, and I'm going to get right after it. And I'm just looking for my section in the book, and there's all these fancy unit conversions. So it's important that you actually read your textbook, and I'm going to risk doing this in front of you because I just switched computers. Other one crashed. So let's see. My math lab, Pearson. Sign in, just like you guys are supposed to do. Those pop-up blockers always appear. Always accept them. AJ Verbsky, 12. Oops, I'm not supposed to tell you my password. That'd be terrible. All right, we're in. And I go look for your class. Here we go. And you go chapter contents, chapter 2, section 2B. The text. Now, see these video presentations? Watch it. It's different than mine. You'll learn quite a bit. It won't. This class will be easier if you watch them. E-text, e-book. Sorry, I had it up on the other computer in advance, so I look professional. But you're just going to sit here and watch me, and hopefully it doesn't fail. I do have fairly fast internet at home, so I don't know what's taking so long. And I think we're close. And 2B, page 89, yes, and at the bottom, check all that out. So if it were me, I would, look through these and see which ones you know. If you don't, you know it's on page 89. So if you're working homework and you get stuck, this is where you look. I grew up in Wisconsin, so I actually knew what a cord was. I made a lot of firewood. I used to do bushel baskets of oats, and we always were tested in FAA, Future Farmers of America, about pecks and quarts and all that stuff, and we had to know all these conversions back in the day. I remember rods because we would be building fence and fathoms, or I think that's for, I don't recall that a fathom is 6 feet, but anyway, horse racing, a furlong. If you give me the conversions, I'm set. So there they are. That's awesome. Another thing I can't replicate is page 91. The metric system, I'll be going back and forth to this right here, doing our conversions and our metric prefixes. So what I'm going to do is I'm going to throw the book over on the other screen and get back to this lecture. So let me see if I can do one here. Convert 279. So I'm working out of the book. This is example 3. Now, I don't work all the examples. I just work some of them. Now, that means if you need more, that's when you read the book. Now, the book is awesome because in the book there's tutorials and there's animations and there's all these extra things you can do. So, yeah, I'm your teacher, but at the same time, you pay for these digital resources, you might as well use them. Watch a video. Watch my video. It will make the class more meaningful. You'll learn more. Granted, it takes longer each section, but you'll feel a lot better about the class. So this is 3A. Here, I'll even tell you what page I'm on, page 93. And convert 2759 centimeters to meters. So the way I work it is I say to myself, I would like to get rid of centimeters, and I would like meters. And I know in 1 meter, there's 100 centimeters. If you don't know that, that's in the table. Now the cool thing about unit or dimensional analysis, the dimensions go away, cross-cancel. So when you divide by 100, you might remember to move it over 2 to the left, or type into your calculator. And there you go. There is conversion from centimeters to meters. I actually teach electronics in addition to this, and this next problem totally reminds me of one of my problems that I just went over with my students in electronics class. So section 3B, you got how many nanoseconds in a milli. Oh boy. Oops, I grabbed the wrong. The book says microsecond. So here's the deal. they go, how many of these? So in a microsecond means 1 microsecond. So I have 1 microsecond. And I'm going to see if I can swing the book back over so I can look at my handy dandy little table here. Micro is this mu symbol. Nano is this n symbol. You see the 10 to the negative 6 and 10 to the negative 9. Okay. Let's see if I can just bring that down. That might be better. So it's 1 microsecond. Now, the way I roll, I want to get rid of microseconds, and I want nanoseconds. But we saw, actually, you're going to see that, I don't look at the book when we're doing this. So we knew there was 10 to the minus 6, which means micro, and 10 to the minus 9, which means nano. Now, 10 to the minus 6 is 1 over 10 to the 6th. And 10 to the minus 9th is 10 to the 9th. Now, one of them has 3 extra 10s in the bottom. So this implies if it's 3 extra 10s, nanos is smaller. And the negative 9 helps you understand that too. So these guys are off by 3 tenths. So I know that in 1 microsecond, there better be 1,000 nanoseconds, since it is smaller, and basically I just talked myself into a circle. So I cross off my microseconds, but I literally answered the question just by logic over here. I'm not going to try to prepare my lesson, like spend a lot of time on it. With you guys, I want to make sure you understand that what we're doing, there's multiple ways to do it, and even a guy like me who's done a ton of math will struggle here and there. So is that a little confusing? Sure. I'm going to use a different approach, meaning the book's approach, which may or may not be better. Let's see. 1 microsecond I don't like their way, but we'll do it 1 nanosecond. So they just divided the two just for the heck of it. Now, the book says that's 10 to the minus 6 seconds over 10 to the minus 9 seconds. And it says to subtract exponents, which we didn't go over, the book didn't go over. So negative 6 minus a negative 9. Double negatives is plus. So you switch those to plus, and you get 10 cubed equals 1,000. I must say I'm not a fan of the book's explanation. So what they're saying is a microsecond is 1,000 times as long as a nanosecond. Not liking it. There's got to be a better way. Well, for right now, I guess I'll go with my way, even though it was not the greatest explanation in the world. It's definitely way better than the book's explanation. All right, everything won't be perfect all the time, that's for sure. Section, going to page 93, going to try to bring the textbook up. Got some powers of 10 work in the book. It's called a brief review. That brief review would probably be the way to go. All right, what's going on here? Page 94. I need page 93, that's why. I don't know why it's blue, but you know, we're on the clock here. So US the metric, 1 inch, 2.54 centimeters, 1 foot. They got all these great conversions here for us. So if you give me the conversions, I'll be able to convert anything. Let's give it a shot. So marathon to kilometers. So example 4 says marathon is 26.2 miles, and I want to convert to blank kilometers. So my method works pretty good. I'm going to try to stick with what I know best. I want to get rid of miles. I want kilometers. So if somebody's nice enough to tell me what 1 mile is to kilometers, we're all good. Let's see if we can look it up. 1 mile, right there. 1 kilometer is, oh, here we go. 1 mile is 1.6093 kilometers. 1.6093. 1.6093 miles cancel. Therefore, 26.2 times 1.6093. 42.16366. Don't know where they're rounding. They don't say how long. Pay big time attention to MML. Let's just go 3 decimals for sure. The 6 pushes that to a 4. So 42.164. Oops, most importantly, kilometers. This is also a good problem because it converts something squared. So example 5, when they want to do 1 mile squared, that's really 1 mile squared. I don't like their parentheses when they did that. So it's 1 mile times 1 mile is really 1 times 1 is 1. Well, here I can do the work. So they were going 1 mile times 1 mile. So they're saying it's 1 mile squared. I don't like doing that because we all know 1 times 1 is 1, and mile times mile is mile squared. I wish they would have started here. But if you want to go to kilometers squared, you got to get rid of a mile. You got to get rid of a mile again. And 1 mile is 1.6093 and 1.6093 again. And the mile cancel out the mile squared. And those were kilometer or kilometer and kilometer, which is going to give me 1.6093. I got a squared button, and I get 2.58984. If you're looking at the 3, the 8, ooh, this is a tough one. The 9 becomes a 0. The 8 becomes a 9. 5. Woo! That was hard. Now, they do a little bit on temperature conversion between Celsius and Fahrenheit and Kelvin. I remember 32 degrees is freezing in Fahrenheit, and 0 degrees is freezing point in Celsius. And isn't it negative 273.15 degrees Celsius is actually Kelvin or something crazy like that. Absolute 0, the coldest it can be. Well, if they ask you questions on temperature and you're not sure, just turn to page 95. Remember, this lecture is not complete. That's why you read the book. That's why you watch the videos in the book. That's why you watch my videos, so you get the whole story. There are some great equations that they actually gave you, so I'm going to try one. These are the ones that I commonly work with. I'm not going to show you the book. So 1.8 Celsius plus 32, that converts Celsius to Fahrenheit. And Celsius equals Fahrenheit minus 32 over 1.8 converts Fahrenheit to Celsius. Kelvin is Celsius plus 273.15, and Celsius to Kelvin, or Kelvin to Celsius, I feel like I'm back in science class, but I also feel pretty comfortable because I'm a math guy and I like formulas. I feel really comfortable. You may not, we don't have to be the same. I guarantee you're in some areas way smarter than me because sometimes logic fails me. I'm great analytic. I'm a great big picture thinker, but sometimes some of the simplest things throw me. If you looked up my solutions for 2A, you see it. You can see I'm vulnerable here and there. I'm really good on calculus, but some of this basic stuff, it's number one, I may not have learned it when I was a kid, or now it's new math and all that. So, it's just working it one by one here. Anyway, we know we're 98.6, so this is example 7, as I said. We're supposed to be 98.6 Fahrenheit on average. Now, that's a lie. I know for sure I'm run like 97.9. I am not 98.6. I had my temperature taken a lot when I was in college because I always gave plasma and they always took my temperature and I was running low. So, been that way in my entire life. But that's the average temperature of the human body in Fahrenheit. What would that be in Celsius? Well, you just jam in that right there. Now you do the top first because it's like invisible parentheses. So, and then these fancy calculators, oops, you got parentheses, so you can do it all in one stroke. Or you could get the numerator, write down the denominator, then divide it like that. But we get 37 degrees Celsius. So if they ask you to do conversion, that's what you do. Now, I see some more units. There's just tons of units here. Here's a power conversion. Now, I don't know how much we need to know about power, but this is just a good problem to work. So the energy units are joules. Now, you don't need to understand it. To be honest, I'm studying volts right now in electronics, and the units for volts are joules. Let me see, joules per second? No, that's coming up. I think that's joules per watt. We'll get it figured out here. But anyway, that's not important. The units are joules. So use J, and the unit's a joule. Now, power is said to be measured in watts. I put triple equals, is said to be watts. Power is the rate at which energy is used. So they say power is really a watt is a joule per second. It's the rate of energy. So they got this example 8. And so what? We don't have a background in this. As you ride an exercise bike, and this happens all the time to me, the display says I'm using 500 calories per hour. My Apple Watch or iWatch, whatever you guys call them, it gives me calories per hour. I don't think I'm about to learn something. Are you generating enough power to light a 100-watt bulb? Well, they're going to tell me something about a 100-watt bulb. So a 100-watt bulb and just so you know, 1 calorie is equivalent to 4184 joules. Well, thank you for telling me. That's my multiplying factor. So 100 watt. So we're trying to get 100 watt, but watts are really joules per second. So we want to convert this guy to joules per second. And if it's over 100 joules per second, then you are creating enough energy to light the light bulb. Okay, here we go. 500. How about let's go cal per hour. Now I want to get rid of calories. And I want to get joules. And then you look, 1 calorie is 4184. And the calories are gone. But wait, I want seconds. So in 1 hour, here, let's do it the long way this time. In 1 hour, I want to get rid of hours. There's 60 minutes. So I got joules per minute. But wait, I can get rid of minutes. And I want seconds. And in 1 minute, there's 60 seconds. And minutes cancel, and you can see I get joules per second. A lot of fun. Then you just book straight across, and you can see it's really 500 divided by 3600. Oh, times this. So let's go this times this on my calculator, and this time let's just do a baby step. 500 times 4184. Whoa, that's a big number. 2092 with 3 zeros. 2092 with 000 divided by 3600. Get rid of some zeros, and then get the calculator out. So divide this number by 100. That kills those 2 zeros. So 20920 divided by 36. Woo! 581.11 repeating joules per second, which is 581.11 watts, which is more than enough to light the light bulb. Let me see. Yeah. Oh, Siri's trying to talk to me. Actually, you could not only light one. Here. Color this in. That's yellow. You could have 2, 3, 4, 5, and technically like a 70-watt bulb, because this is only 500 watts. So we can light 5 light bulbs for sure. We got it going on. All right. I don't know about you, but I really enjoyed that problem. The only issue is I have to remember all that stuff, and I don't bring my calculator when I work out on my, well, maybe I do. Sometimes it's on my iPad, but I try not to bring my calculator. So, pretty good problem, really. Something else that always bothers me is my electric bill. So I got my electric bill. By the way, I try to keep my lectures around 30 minutes, so regardless of where I'm at, ooh, it's gonna be close enough. I'm gonna try to stop in 5 minutes. Electric bills. They give you in terms of kilowatt hours. 1 kilowatt hour is equal to 3.6 million joules. I think they meant this. I feel way better writing 3.6 million out as 3.6 million. Wow. Now the company charged me 15 cents for a kilowatt hour. So I'm in example 9, and it will be my last example of the evening or whatever time of day you're watching this. Example 9 is 15 cents per kilo. I just write it all out. Watt hour. How much does it cost to keep a 100-watt light bulb on for a week? Whoa. So you got a 100-watt light bulb on for 1 week. Well, I think I'm going to start with this. So we got 100 watts, and we're going to get rid of watts. Doesn't mean no good. And I want to convert to kilowatt. In 1 kilowatt, there's 1,000 watts. Now times 1 week, because it's kilowatt hours, kilowatt technically times hours, kilowatt hour. So we got to throw some time in there. So we got to get rid of weeks. And let's throw in some days. And in 1 week, there's 7 days. But wait, I want to get rid of days. And I want to get into hours. So an hour. In 1 day, there's 24 hours. And look at this. The watts cancel. The weeks cancel. The days cancel. Look what you have. Kilowatt hours equals, well, you multiply straight across, and you're going to divide by 1,000. And trust me, you get 16.8. And I wish they abbreviated this, but they don't. Kilowatt hours. And I wish they went to use the hyphen in the book. I just wish they would have went times, because that's what it is. Kilowatt times hours. Now, if you got 16.8 kilowatt hours, and it cost 0.15 cents, times 0.15 cents or dollars, per kilowatt hour, you have just dollars left. And 16.8 times 0.15 equals $2.52. Well, I'm at my limit, 35 minutes. It's a long time. I'm going to work my assignment in section 2B and see how bad it is. And then if the assignments are really tough, I'll just start, making a video of the assignments. I thought personally 2A was a little challenging here and there for me. I really struggled at the beginning. All those words in section 2A were killing me. I'm hoping this section is more mathy because that's what I'm good at, but that may not be the thing for you. A lot of you have logic, which I wish I was more like you. I'm very, very algorithmic and structured in my math thinking. Well, anyway, you may or may not like this format. I'll tell you, some of my lectures are better than others just because I work this stuff all the time. This section here, it's been a while since I've given a lecture, but I really, really like the material, and I find I do use it in my real life outside of math. So the kilowatt hour bit and unit conversions help me here and there. I always converted Celsius to Fahrenheit, that type of stuff. Well, anyway, that's it. I'm going to turn around and make a MML assignment over 2B. And once again, here's the strategy. It's watch this video, consider watch book, video, or read book. And I strongly suggest going through some of the animations, and they'll force you to watch a video maybe. And then finally, work MML. We're in no hurry. We're in no hurry whatsoever. We only are covering 5 chapters, it turns out. And it looks like if we go slow enough and just, get the section down, we're going to be in good shape. Anyway, work MML, it's going to be section 2B, and I'll be picking those problems here in just a little bit. And of course, I'm going to try to pick them with respect to the lecture I just gave. That's it. Name's Verb, 720-985-1986. Got any questions, give me a text. Been pretty good about getting back to you guys. Good luck. Let's see if I can end this.